Alright, last time we learned about all the angle pair relationships that were created when two lines were cut by a transversal. Today we're going to take that same scenario and find out what happens when those two lines that are cut by the transversal are parallel lines. So, when parallel lines are cut by a transversal, the following pairs of angles are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. And alternate exterior angles are congruent. And there's actually postulates and theorems that talk about each one of these angle pairs being congruent when those two lines are parallel. And I've written the names of those postulates and theorems right over here. But we write in the notes like this instead of making you write out all the words over and over again with each postulate and theorem. So the corresponding angles postulate says that corresponding angles are congruent when parallel lines are cut by a transversal. The alternate interior angles theorem says that alternate interior angles are congruent when parallel lines are cut by a transversal. And the alternate exterior angles theorem says that alternate exterior angles are congruent when parallel lines are cut by a transversal. Now, not all angle pairs are congruent when parallel lines are cut by a transversal. Some of them are supplementary. So, whenever two parallel lines are cut by a transversal, the following angle pairs are supplementary. Same side interior angles and same side exterior angles. So out of all these angle pair relationships that are created by two lines and a transversal, there's only two that are supplementary, and it should be easy to remember which ones. They start with an S, just like the word supplementary. And then the other ones are congruent. Now, a quick refresher on some of the angle pair relationships that happen at the same intersection. What angle pair is always congruent regardless of whether lines are parallel? Vertical angles, because vertical angles are at the same intersection. So the two lines being parallel is completely irrelevant. And what angle pair is always supplementary regardless of whether the lines are parallel? Linear pairs. And again, linear pairs happen at the same intersection, and so they're always supplementary, and it doesn't really matter if the lines are parallel or not. And again, vertical angles theorem is the one that tells you that vertical angles are always congruent. Linear pair theorem is the one that tells you that the two angles in a linear pair are always supplementary. Alright, example 1. Tell whether each type of angle pair, or show me what type of angle pair each is, and tell whether they are congruent or supplementary. So angle 1 and angle 3. Angle 1 and angle 3. Notice angle 1 is in the top left-hand corner of the intersection. Angle 3 is in the top left-hand corner of its intersection. They're in the exact same place at both intersections. Those are corresponding angles. And if you think back to what we just finished talking about, because these lines are parallel, notice the arrows marking these two lines parallel, I know that they're either going to be congruent or supplementary. If I go back up here and refresh my memory, the corresponding angles are always congruent when those lines are parallel. So we're going to say that they are congruent. And I'm just going to write the congruent symbol instead of writing out the entire word. Okay, angle 3 and angle 6. Angle 3 and angle 6. Notice this is the transversal, and they're on different sides of the transversal. And notice they are inside those two lines, so they are interior. So those are alternate interior angles. And if you refer back up to the top of your notes, alternate interior angles are congruent when lines are parallel. Okay. Angle 4 and 5. Angle 4 and 5. Notice they are on different sides of the transversal. 4 is on the left side of the transversal and 5 is on the right side of the transversal. And notice they are not interior. They are not in between the lines. They are outside the lines, so they are exterior. So these are alternate exterior angles. And again, we said when the lines are parallel, alternate exterior angles are congruent. Okay, angle 2 and angle 3. Angle 2 and angle 3 are both on the same side of the transversal, and they are in between those two lines. They are interior, so those are same side interior angles. And notice it starts with an S. Same side interior angles are supplementary when those two lines are parallel. So they are supplementary. And we're just going to abbreviate it. Sub. Alright, angle 1 and angle 6. Now notice angle 1 and angle 6 are at the same intersection. The same intersection. So if you got an intersection of two lines, the only angle pair relationships that are created are vertical angles and linear pairs. If they're adjacent, if they're side by side, then they're going to be linear pair. If they're across from each other at the intersection, then those are vertical angles. And angle 1 and angle 6 are across from each other at that intersection. Those are vertical angles. And vertical angles are always congruent. Okay, angle 1 and angle 4. Angle 1 and angle 4, notice they're on the same side of the transversal. And they're both outside the two lines. They're exterior. So those are same side exterior angles. Exterior. And again, starts with an S. Same side exterior angles are supplementary when the lines are parallel. Alright, for each of the examples below, identify the type of angle pair, and given that lines L and M are parallel, find the value of x. So very important. They didn't mark them parallel in the picture, but they gave us this information in the directions. So I know that lines L and M are parallel to each other. So all that information we just learned applies in this situation. So let's identify these two angles that have expressions on them. They're on different sides of the transversal. They're inside the two lines, so they're alternate interior angles. And we learned alternate interior angles are congruent when the lines are parallel. And when I know two things are congruent, I set them equal to each other. Because remember, congruent means equal measures. They're going to be the same number of degrees. Alright, so now we're just solving an equation. We don't want x on both sides of the equation, so we get rid of one of them. Once we got x in one place, we want it to be all by itself. Anything on the same side of the equation's got to go. Alright, so I found out x was 30, and that was based on the fact that I knew that these were alternate interior angles. Because that's how I figured out that they were going to be congruent to each other. Because they were alternate interior angles, and those lines were parallel. Okay, on the next one, notice these two angles that have expressions are on the same side of the transversal, and they're in between the two lines. So these are same side interior angles. And if you will remember, same side interior angles are supplementary when those lines are parallel. And again, these directions for up here applied to all of these problems we're doing right now. It told us that lines L and M are parallel to each other. And so we know they're supplementary. That means that they add up to 180 degrees. So I take that information and set up an equation just like that. If I know they add up to 180, I'm going to add them together and set it equal to 180. So I add those two angles together, set it equal to 180 because I know they're supplementary because they're same side interior angles and these lines are parallel. From here, we're solving the equation. So first, combine like terms that are on the same side of the equation. 8 minus 32. Okay. Add the 24. Trying to get x all by itself. and divide off the 6. We get x is 34. Okay. Example 4 will throw some people off just because of the way it looks. But there's an easy way to make it look like what you're used to. Just extend these. And all of a sudden, it'll start looking more like what you're used to seeing. Now, it told us in the directions up at the very top that lines L and M are parallel. So I know that these lines are parallel to each other. So then this is the transversal. And here we have these two angles labeled with variables or expressions. Now, if I look at these, they're on different sides of the transversal. But one of them is interior and one of them is exterior. So it doesn't fit either category. Now, the only angle pair relationship we learned that doesn't have interior or exterior attached to it is corresponding. So this angle is in the top right-hand corner of its intersection, but this angle is not. It's in the bottom right-hand corner. So they're not corresponding angles. These two angles that they've given us expressions for don't fit any of the angle pair relationships that we've learned. So we got to think about this in a different way. I want to take this expression I have for this angle and put it in a different place. I want to put it on another angle that I would know would be congruent. So for example, corresponding angles, same place at the two different intersections. X is in the bottom right hand corner over here. Those two angles are corresponding angles. And we just learned a moment ago, if these two lines are parallel, corresponding angles are congruent. So if this is X, I know this angle is going to be X because those two angles are the same measure. They're congruent to each other. Now, while these didn't have a specific relationship that we had learned, these angles do. They're at the same intersection and they're adjacent to each other. These are a linear pair. And we've learned that linear pairs are always supplementary. They always add up to 180 degrees. So the two angles that they originally gave us had no relationship to each other. But these two angles are a linear pair. I know that if I add them together, it's going to equal 180 because I know those two angles are supplementary. So now we combine like terms. You got x and 3x, that's 4x's. You want to get x all by itself, got to get rid of this 40. It's being subtracted, so I'll do the opposite and add it. And then x is being multiplied by 4, so we divide by 4, doing the opposite operation to get rid of things. And x is 55. Alright, let's find the values of x and y. So we'll do one at a time here. Alright, so let's look at where we got x. Here's x. We need to find some angles that it has a relationship to. Now notice the arrows here. We got the single arrow and single arrow, meaning these lines are parallel. And then we have the double arrow and double arrow, meaning these lines are parallel. So let's see. Again, this is in a form that maybe you're not used to seeing it in, and so maybe it's not all clicking just yet. Do what I did on that last one, and let's extend the lines. So let's take these parallel lines. I'm going to extend it out a little bit just to help you kind of see hopefully what you're needing to see. And then this angle with the x on it is created by this line and this line. So this is going to be our transversal. It's intersecting those two parallel lines, right? So try to block out the rest of the picture for right now and see these parallel lines and this transversal. And notice this angle that's labeled 3x has a relationship to another angle that's also along the same transversal. What about these two angles right here? Created by the same transversal and then by those two parallel lines. They're on different sides of the transversal and they're in between the parallel lines. These are alternate interior angles. Alternate interior angles. And we learned that when these lines are parallel, which we know they are based on those arrows, the alternate interior angles are congruent. So I can say 3x equals 99. and then I can solve for x. So I know x is 33 degrees. Okay. All right, I'm going to do the same basic idea with the 2y. I need to solve for y. Here's y. It's created by these two lines. Okay, so this is one of the lines it's created by, and it's parallel to this line. So I got these two lines, and then 2y is also created by this line. So this is our transversal. So focus on these two parallel lines and this transversal. And you should see another pair of alternate interior angles. These two angles are both created by those parallel lines and this transversal. And they're on different sides of the transversal, and they're in between those two parallel lines. Those are alternate interior angles. And just like the last pair, we know when those lines are parallel, alternate interior angles are congruent. When things are congruent, we set them equal to each other. From there, you just solve in the equation, and we find out y is 9. All right, let's try the last one here. All right, example 6. Let's label the picture with the information we have. The measure of angle 3 is 8x plus 3. The measure of angle 4 is 20y minus 3. And the measure of angle 7 is 11x minus 12. Find the values of x and y. Alright, let's say I want to solve for x first. We have x in two different places right now. We got it here and here. So I need to see if there's a relationship between those two angles if possible. Well, this line right here is part of this angle, and it's part of this angle. So this is going to be our transversal. And notice the angles are created by, this angle is created by this line as well, and this angle is created by this line as well. And notice they have the arrows on there to show that they're parallel to each other. So you got parallel lines cut by a transversal, and angle 3 and angle 7 are what type of angles? Just like on the last problem, we have some alternate interior angles. They're on different sides of this transversal, and they're inside those two parallel lines. Those are alternate interior angles. Just like we said last time, if these lines are parallel, which they are, alternate interior angles are congruent. So again, when I know things are congruent, oops, that was a mistake. When things are congruent, I set them equal to each other. So then we're just solving for x. Don't want x on both sides, I'm going to get rid of one. I always get rid of the smallest one. Gives me a positive coefficient, a positive number in front of the x. Then I want to get x all by itself. Move the constant first. Always use the opposite operation to make that happen. And then divide off the 3. X is being multiplied by 3, so we do the opposite and we divide by 3. We should get x is 5. Now we need to find out what y is. And y is part of this angle right here. I don't have any other angles with y in it. And I haven't been given any other angle measurements. So I got to come up with another way to do it. Well, we just finished solving for x. I could substitute this 5 in for x on either one of these two angles and find out what they are. And I could really use either one. If I look at angle 4 and angle 7, they're on the same side of this transversal and in between the lines. Those are same side interior angles. We learned same side interior angles are supplementary when the lines are parallel. So I could substitute this in for x, find out what this is, and know that these two add together to equal 180, supplementary. Or I could substitute 5 in here for x and find out what this angle is. And notice angle 3 and angle 4 are a linear pair. They're at the same intersection, side by side. They're sharing a vertex, sharing a side, and they're creating that straight angle. They got opposite rays for the non-common sides. Those are supplementary as well. So I could substitute 5 in for x here, find out what that is, and these two would add up to 180. Either way, I should get the exact same answer. So it really doesn't matter which one you want to do. So I'm just going to substitute it in here. So I'm going to take that 8x plus 3, substitute 5 in for x, because that's what we know x is now. 8 times 5 is 40. 40 plus 3 is 43. So I just found out that angle 3 is 43 degrees. And remember, this is a linear pair. They're supplementary. They add up to 180. So I'm going to add these together. I'm going to take 43, add it to 20y minus 3, and set that equal to 180. And we're going to solve that equation. So first things first, combine like terms. We got 43 minus 3 is 40. Subtract off the 40. Divide off the 20. And you should get that y is 7.